Hello and welcome to this presentation on spreadsheets, which serves as both an introduction and covering the formulas which are required in the study design. The intended audience of this is VCE students in Units 1 and 2 computing, but I have to say I'd be very surprised if you didn't know this stuff by the time you got to year 11, and it's possible that I will use this with younger year levels as well. So our learning intention is that students can identify the key features of spreadsheets and can use 5 common functions. First of all, what is a spreadsheet? Well, a spreadsheet is a digital document consisting of rows, so rows are going that way across, and columns, forming a grid of cells. Now, some people just use it like grid paper, but it's so much more powerful than that. This is actually the very first spreadsheet, which is called VisiCalc, and that's on an Apple II, which is the precursor to the Macintosh. This is actually, the Apple II is the computer that made Apple Computer fabulously wealthy the first time round, and this was pre-GUI. So this is before point and click. So spreadsheets are used for organising information, for calculating, and I think this is the key benefit of a spreadsheet. Analysing, you can do all sorts of amazing things with it, and you can analyse numerical and textual data. It's quite powerful with numbers, it's quite powerful with text. So what do we use it for? Well, it enables us to perform complex calculations, to create charts, and to manipulate large data sets. Excel in particular, and all spreadsheets, are amazingly used everywhere from high school to, our major statistical bodies. And I say that having seen that firsthand. This one over here, this is Lotus 123. This is actually the original, as far as I know. Oh, actually, no, sorry, it isn't, but it's one of the early Windows versions of a spreadsheet, and this is from 1992. So as you can see, this looks very much like Excel, but before Excel was popular, people used Lotus 123. They coexisted for a while, not all that long. Just before I start telling you about the features, this is from the first version of Excel, and the first version of Excel was actually made for a Macintosh, because in these days Windows was not a thing, it was all DOS. And so the point and click version of this, which you can see, runs on the Mac before it ran on Windows. The one on Windows was in that last image. So their cells are referenced by the column they're in, and they're labelled A, B, C, D, and then once we run out they become A, B, B, C, C, and row numbers. And they go from 1, there's no 0, and they go down to, actually I don't know what they go down to. I think there is a limit, but I don't know what it is. You can put numerical and text data. Actually, I'll show you something interesting over here. You'll see that I've got all those numbers there and they're sitting over to the right. But if I type text, it actually sits over to the left. So you can actually tell just by looking at a spreadsheet whether it's regarding it as text or as a string, just by where it's positioning, which I think is very clever. And it supports mathematical and logical formulas about things being true and so forth, as well as just maths questions. And the great amazing thing about it is that it's automatic updating. You don't have to say to it, hey, go do this calculation. Just if it's got a formula to do it and the data's there, if you change the data, it changes the calculation. I think it's a revelation. And there is graphing and data visualization capabilities, and lots of people use it for that. It's a very good graphing tool. That's in another video, that's not in this one. So this is not in the study design, but I figure if they're going to do the elementals, let's start with the most elemental. If we want to add things up, you click on a cell where you want the value to be. So I've clicked on A11 and I've typed equal sum brackets A1 full colon A10. So what I'm saying is the equal says I want you to do the calculations. What calculation do I want you to do? The sum. And what data do I want you to do it with? A1 to A10. And then when I hit enter, it gives me the number. So they add up to 230. All the while, up here, if you click on that, you can see the formula. And if I double click back in that cell, I'll be able to see the formula again, but it is hidden from you when it shows you the answer. You don't see both the formula and the answer at the same time. So that's how you do sum. Average, also known as the mean, is equals. Hey, you do some work, what work? And average, here's the range, and that average is 23. The median is if you line the numbers up from lowest to highest. Now, in this particular example, they're already lined up lowest to highest, but that's not a precondition. They could be completely jumbled, and Excel can still just go straighten them up in its head and say, there's the middle number. It doesn't actually need to sort them. This is actually in Google Pages. What was that last one in? Oh, that last one is in Google Sheets, and this is in Apple Pages. I like this one. I like the interface of it. I don't use it very much, but it's quite cute how it kind of validates that you've got the right imports and so forth. And so that's the median in Apple Pages. This is count. I think we're back in Excel here, and the formula is equals count. Here is frequency. Now this is called count if. So what we're saying is, I want you to count values of the cell. There's the range, A1 to A10, and count them if they're 15. So I'm counting the 15s. So that, and down here you'll see that there's 2. And if I look back up here, there are in fact 2 cells that have 15 in it. This next one is called a standard deviation. Now, you may have heard of standard deviation. When I was in high school, I certainly hadn't. So standard deviation, ST-Dev. There's also ST-Dev S and P, and they're more sophisticated concepts, but this one works in all three, and the standard deviation is 9.69. Now, you may very well ask yourself, what is a standard deviation? Well, most data, when you collect it, falls into this thing called the normal distribution. Well, not most data, but a lot of data falls into this. You know, you have a whole lot of people who are the average height, and a few people who are taller, and a few people who are shorter, and all sorts of things. And so there's this concept which is the standard deviation, because sometimes you have it really flattened and spread out, and sometimes it's really peaked. And so let's say I get a score here. Well, that score, if I know that it's more than one standard deviation away, then I know that it's actually higher than, 67% of the data. So it's sort of unusually high. Whereas if I get a score that's here, well, it's very much, not only is it close to the mean, but in actual fact, there's a lot of people in the same boat as me. I think about this when I do the pivot data for school. So that's a fairly normal spread of data. This one is tighter. So in actual fact, I could get a score on that last one. Let's say my score is about, it's a little bit hard to do, but in here, if my score's there, I'm exceptional. On that earlier one, I might have a score up here, and I might be, I'm unusual, but perhaps not exceptional. By the time you're getting up here to 2 standard deviations away, you're in the top 0.3 of the population that's being represented. So you can have the data very concentrated, and you can have the data, which one? Hang on, so there's what I'm going to call normal. There's where it's concentrated, and there's where it's spread out. So in here, I might be here and think, I'm miles away from the average. Look at me. But in actual fact, lots of people are miles away from the average because the data is quite flat. So how many standard deviations you are away from the mean is actually a measure of kind of how exceptional you are. It's much more meaningful than just how do I compare to the mean. Ask your maths teachers how that all works. That's about as deeply as I understand it. All right. The last thing I'd say before we test our knowledge is that spreadsheets are like fighter planes. They are unbelievably complicated. There would be hundreds of things that you can do with a spreadsheet, and I know how to do about 10 or 15 of them. Really proficient users might know how to do 30 or 40. There are actually contests where people compete, like in front of an audience and for prizes, to do amazing things in Excel. But we use it from primary school all the way up to, statistical agencies. It's an amazing piece of software, but almost nobody knows it all. But let's see how you go on the basics. So you're going to send me the formula. What's the formula for the total of the numbers from A1 to A10? If you're playing at home, it's equals sum, brackets, A1, full colon, A10. Mean is equals average, and then the range. The median is actually just what it looks like. So it's equals median. And then the range, of course, it always includes the range. Number of entries is count. So it's equals count and then the range, and it'll tell you how many entries are in that range. And the standard deviation is STDEV, or equals STDEV brackets and then the data set. So this is a very cursory overview, but actually that's all it asks for in the curriculum. So if you've learnt something, well and good.